All right, so what I'm going to do is I'm going to review equilibrium. So this is the Kung Fu Review 7 to review equilibrium. So basically, when you do your Kung Fu quiz tonight, it'll be a piece of cake. So what's the definition of equilibrium? Definition of equilibrium means the forward and reverse reaction rates are equal. What does that look like when you see it on the graph? Remember, the concentrations don't change. Because the forward and reverse reactions are at equal rates, there's no change in concentration. Something's happening, but you can't perceive a change as far as concentration. We just reviewed kinetics. Kinetics, concentrations are changing. Equilibrium, you see that you basically have no concentration changes right there. How do you figure out an equilibrium constant? Remember, it's products over reactants. You use the stoichiometric coefficients. They turn into exponents. So like e and little f there become exponents in the top. Products always go on top. Reactants always go on the bottom. Remember never to include nunca, little Spanish there. Never include solids and liquids in your equilibrium expression. So you want to keep those out of the expression. One of the things they ask you on the free response, not so much on the multiple choice, and it's on the free response problem, you have to do it for homework tonight, is converting KP to KC. It is in your booklet. So if you're given KP and they want you to find KC, or they give you KC and they want you to find KP, you just plug and chug. So you're either going to plug either one that you're given in here or here. R times T. The R is the gas constant, so it's going to be 0.0821. Delta N is numbers of products moles of products, minus moles of reactants. This equation is in your exam booklet, so it's not like you have to memorize it, and I ask you to use it on the free response problem tonight. Le Chat. Le Chat occurs in multiple choice all the time. There are 3 situations where you have Le Chats that you have to apply. Basically, that's where you put stress on a system, which causes the system to restore the equilibrium ratio. Remember this, if you add, put a plus sign on whatever you're adding, and the reaction will automatically shift to the opposite side, away. It's add away. When the arrow goes to the opposite side, automatically the concentrations to the side where the arrow is going increase. The area where the arrow left, those decrease. So when you add or increase, causes a shift to the other side of the equation. Take towards. If you take or remove something, put a minus sign above whatever the species is. Remember, the arrow will go towards that. That means that side, the concentrations on that side of the equation will increase. Where the arrow is leaving from will decrease. So if you take or decrease, you go toward that side where you're removing something, either a reactant or a product. All right, temperature. Remember, endothermic and exothermic have to do with heat. So if it says exothermic, that means you write the word heat on the right-hand side. Have to know that as a chemistry student. So heat goes on the right-hand side. If I say something's endothermic, I put heat on the left-hand side. Then the same rules work. Basically, if I increase temperature, increase heat, it would be me putting a plus right here. If I add, it causes the reaction to shift away. Concentration of A and B are going to get bigger. C and D are going to get smaller. So A and B are going to go up. C and D are going to go down. Remember, the only thing that changes K is changes in temperature. We solve for KEQ like this. Products over reactants. So in this case, if the reactants get bigger and the products get smaller, whatever happens to the products happens to KEQ. Since the products are decreasing, KEQ is going to decrease. What happens if I take this reaction? If I increase temperature here, add away, it's going to shift this way. C and D are going to increase. A and B are going to decrease. What's going to happen is my products are getting greater. My reactants are getting smaller. Guess what's going to happen to KEQ? It is going to get larger. The only thing that changes K in any Le Chat problem is going to be a change in temperature. Next one is pressure and volume. Remember from Boyle's law, we did gases a little bit ago. Pressure and volume are inversely related to each other. It's like a teeter-totter. Pressure goes up, volume has to go down. So if you look right here, it's listed right there. Volume goes down, pressure goes up. When pressure goes up, you go towards the smallest number of moles on the whichever side that is in the equation. If volume goes up, pressure goes down, and you go towards the largest number of moles. This is just straight memorization. You just have to make sure you have it memorized. Count the number of moles. If they tell you, as soon as they mention pressure or volume in a problem, the first thing you should do is total the moles on the left and the right-hand side, and it'll give you an idea of which way the reaction is going to go. All right, Q. When we ask you to find Q, it's like we're trying to find where we are in relation to SeaWorld. Remember when I talked about it in class, we're either going to be before SeaWorld, at SeaWorld, or after. So basically, how do you find Q? All you do is you take the equilibrium expression, toss the numbers that you're given into it, and you get a value. You compare it back to the K. If Q is less than, means the reaction still has to keep going forward. If Q is greater than K, that means we went past SeaWorld, we have to go backwards. And if Q and K are equal, means we're in the parking lot at SeaWorld and we're at equilibrium. Here's a visual example of it. When Q and K are equal, we're at equilibrium. If Q is smaller, we say the reaction is going to go forward. If Q is greater, to reach equilibrium, we say the reaction is going to go backward. Now, here's an example of an equilibrium problem. Remember when we do equilibrium problems, we did a bunch of them. On the multiple choice, they have you back solve problems. That's what it's going to be. So if you look at the reaction is C plus D plus C arrow equals D plus 2E. First thing I'm going to do is I'm going to make a little ice box or an ice table, whatever you want to call it. So I'm going to make a little ice box. So what I do in here is I'm going to fill it out with any value that they gave me. Well, I know right now that the initial value, the only thing they talk about is initial concentration of C is 0.80. So I'm going to put 0.80 right there. This is 0 and 0. My change line is going to be minus X plus 2x. Then I drop everything down. I get 0.80 minus X, X, and 2x. They will always give me an E-line value. At equilibrium, they say C is equal to 0.20. So I have 0.20 at equilibrium. That means I can algebraically solve for X, and they will have you do this on the multiple choice, and there's some on the Kung Fu quiz. So I go 0.80 minus X equals 0.20. What does X have to be? Well, X comes out to be 0.60. So X is 0.60. So then you plug it here. That means this is 0.60 here, and this is 1.20 right there. And that is how you back solve on an equilibrium problem. Write out the initial I-line values, plug in the change values, drop them all down to get the E values, and then one of the values, especially on a multiple choice question, will be provided for you so you can back solve. Here's the example of the free response question you have to do tonight. If you look right here, the first thing is they ask you to write the expression. Products over reactants. Since it's KP, remember you're not allowed to use brackets. You have to use the little P symbol instead. You can look it up if you need to. The next thing they ask you to do is find Q. Well, Q is you take the expression that you wrote in A, plug these numbers in. Beware of the exponents. Make sure you use the correct exponents. You will calculate a value. When you get that value, you're going to compare it to that. Q will either be larger or less than, probably not 0. The next step they ask you is convert Kp to Kc. That was the equation I showed you earlier in the video. That's this equation right here, right there. So you plug those values in and solve. And then the last thing is reaction flipping. I really only, on the homework tonight, I only want you to really focus on the I one. Remember, when you flip an equation in equilibrium, when you flip it, you have to take the inverse of the K value. If you multiply or divide, you take that same value and you raise it to that exponential power. So that's what you have to keep in mind. Those are keys to remember. If you're adding two equations together in equilibrium, in Hess's law, we added them. In equilibrium, if you were taking two equations, you have to multiply the K values instead of adding them. And that is everything you need to know to do very well on the Kung Fu quiz tonight. You want to take it, make sure you do the free response question, the FRQ, and then you want to load your answers onto QuizStar, and then I will see you tomorrow. Have a good day.